Okay guys, welcome to our second video where we're going to look at multiplying and dividing rational expressions. So similar to what we had before, we first have to factor everything. However, you'll notice the steps here are a little bit more compact because unlike number 2, we don't need to figure out what an LCD is and then multiply by the missing piece to the top and bottom of our fractions. So remember, when you are multiplying or dividing fractions, you do not need a common denominator. You either multiply across or you do the keep, switch, flip. And then at the end, we're going to see in this one, we'll typically have things that cancel out or simplify to make a 1, and I'll kind of show you guys what that looks like. So our first step is we want to factor everything. So I'm going to pause the video and factor everything that I can. Notice in both number 3 and 4, some parts are already factored for you. So double check each of the other 3 parts of your fraction just to make sure you've gotten everything. Okay, so I have factored each of the other pieces. Notice the top one here is a difference of squares, right? Remember, you need the +2 and the -2 in order for the area model to have them cancel out. That should be pretty fresh in your head because that is a really close idea to what we saw with the conjugates, right? Where we had the 2x minus 2x. Same idea here. That's how we got rid of these square roots when we did rationalizing the denominator. So keep that in mind, right? It should be pretty fresh. The bottom piece there, the 3x plus 1 times the x minus 2, that was figured out by a guess and check. Because the 3x is there, when you multiply, notice the 3x and the 2 make a negative 6x. And those do combine correctly to give us the negative 5. For this one, the big question is where to put the 2 versus the 1. And what signs. Remember, for guess and check, you just play around with it until you get it to work. Or if you prefer the AC method, if you're a fan, you can also use the AC method. And then the top one had an x squared as the greatest common factor. Remember, you always want to check if there's a GCF first before you do anything else. Do notice it's 3x plus 1 because if you were to redistribute it, x squared times 1 would give you the x squared. So make sure you do put that 1 there. Some people forget to put a 1 and just make it 3x by accident. But then you only have 1 term and not 2. So we have done step 1. We now need to multiply across since it's multiplication. So when I multiply it across, right, top times top, bottom times bottom, it is literally just, pretty nicely everything is just in one fraction. Everything is joined by multiplication. If you write it in a different order, that's fine because remember you can multiply in whatever order. I'm just going left to right. Do notice that x squared minus 2x plus 4 does not actually simplify any further. If these parts look familiar, that is actually that sum of cubes formula we learned previously, but that one has been factored out to make it a little bit easier. So now we want to look for things that simplify. Think about it kind of like if you have something like 4 over 16, right? The top and the bottom are both divisible by 4. So you would divide the top by 4 and divide the bottom by 4. Another way to think about it is 4 is 4 times 1 and 16 is 4 times 4, right? The 4 and the 4, we call that canceling out, but what they really do, sorry about that, is they create a 1. And so that's why we quote unquote cancel them out and say it's 1/4. So we want to look for something that is in the top and the bottom because that will create a 1. So I've got something here, right? I've also got a 3x plus 1 that matches. I'll maybe x those instead. And then let's see what else. I've got x plus 2's. Maybe I'll do those in a different color. And then at this point, you might think that you're done. However, one thing we want to think about is x squared. We can write that as x times x, right? So in reality, you also have an x that cancels out in the top and bottom, or, right, the preferred way I like to think about it is it makes a 1. So on the top, we're left with an x, and in the denominator of our fraction, we're left with x squared minus 2x plus 4. That looks like all that is left. And that is as simplified as possible. Simplifying for multiplying and dividing is a lot nicer than adding and subtracting. Remember, in our previous examples, Our simplifying step happened kind of over here for that final example where we had to put like terms together. We had to distribute a negative sign and put everything together. And the first one, remember, we did our like terms together, and then we could also factor our final numerator. So there's like a little bit less simplification here, which is kind of nice. Our next one is going to be a really similar process, except for the only thing that's going to be different is instead of step 2 being multiply across, we're going to do the keep, switch, flip. So I'm just going to highlight that to remind us that we're doing keep, switch, flip, or keep, change, flip. So the first thing I'm going to do is I'm going to pause the video and I'm going to factor these 3 parts if I can. Otherwise, if I can't, then I just leave them as is. Notice the bottom left was already factored for us. Okay, so I have factored just the top left of the fraction and the denominator of the right fraction. Notice the first one is a greatest common factor, right? You can take out an x because each term has at least one x in common. Remember, you do want to do the plus 1 because otherwise some students will just call that x times x, and then when you distribute, that's just x squared and you're missing your second term. So you do want to put a 1 because 1 times x does give you an x. The second one was also a greatest common factor as well. Notice each of those terms are divisible by 6 and they each have at least one x in common. So that would be your greatest common factor. We've done step 1 of factoring everything. We're going to do step 2 of multiplying across or keep, change, flip. So I'm going to keep my first one, right? Since I'm doing multiplication, I've got to do the keep, change, flip. So keeping this one, change to multiplication. Some people call that switch as well. And then I gotta flip my second fraction. Okay, so hopefully reviewing like these ideas with regular fractions helped you guys kind of conceptualize the big ideas in the first video to review those big ideas. So I've got to multiply everything, right? Top times top, bottom times bottom. I just put everything on top together. And then everything on the bottom together. Notice the x squared minus x plus 1s don't, they can't factor further, right? Because 1 and 1 make 1 when they multiply, but they wouldn't add to a negative 1. So there's no way we could factor either of those parts further. So now we want to do our step of canceling things out that are in the top and the bottom. Remember, canceling is like making a 1, right? So one example is x plus 1 over x plus 1, that makes a 1. So that's why it kind of goes away per se. We also have this whole big piece as well. Oop, and it looks like I did miss, I forgot to write this guy here. Sorry about that. And notice this one's a little harder, so I'm going to kind of write a second step before we write our final answer. We've now got 6x times x, right? And it's all over 3x to the 4th. What I'm going to do is I'm going to kind of write them long ways, like 6 times x, right? It's all joined by multiplication. You can write it in whatever order you want. 3 times 1, 2, 3, 4 x's. You don't have to put the dots if you don't want to. Notice we make 2 1s, right? Those cancel out. And then the 6 over 3, that does simplify to 2 over 1, right? They are both divisible by 3. So 2 3's go into 6 and 1 3 goes into 1. You can also think about that as simplifying 6 over 3. So your final answer is actually 2 over x times x, which you can write as 2 over x squared. So keep that in mind. Sometimes it's a little hard to see those if you have x's and numbers that are separated. That's why we kind of needed to put these two parts together, right, and multiply it all out in order to see what could fully simplify. So that's it for today. On Tuesday, tomorrow in class, we're going to be doing some practice with our rational operations to make sure you guys are feeling good. And we'll go through any questions you guys have about these 4 big problems that we looked at together. I'll see you guys then.